last night's practice did not need to be done. We said that very, very clearly. So when I say get out last night's practice, I'm not checking it. It's not a gotcha. It's nothing like that. We're going to work on it together. So first thing I want is any other questions that you realize you need to ask from Chapter 2 that are not from last night's practice. Anything from any of the previous practice assignments that you still need to finish. Because tonight's homework is, and that's why I turned that diagonal on the homework board, last night's homework is a 2-night homework, like it's worked yesterday and today. But also, because we have a math journal check coming Friday, your homework is really wrap up any Chapter 2 homework that you need to. So last night's homework included, just wrap up whatever. You also then will not have any new homework tomorrow. So if you still have your plan book out or whenever you have it out next, you can write for tomorrow's math homework, no new homework. Or like complete Chapter 2, or I'll probably write something up there like have math journal ready or something like that. So what questions would we like to go over from last night's assignment? We have stuff about converting fractions, Cecil's tightrope. We have all kinds of different situations. These are on the mastery, guys. The point of closure is to be ready for the mastery assessment. So what either did you struggle on or you just haven't done and would like me to do? Marvin, my man, thank you.
Cecil's tightrope.
So 131? Yeah. Sweet. Suppose that Cecil the tightrope walker can only travel lengths of 5, 6, and 8 feet. There are problems like this on the test. I can't say it any clearer. Like this exact problem essentially is on the test. So let's look at how we can most efficiently create the tightrope of the length provided to us given the lengths that we're allowed to use. So if you are writing in your math journal, which you probably should be, you would probably have a header of your homework, but if you don't have a header from your homework and you're just writing down notes for today, today is 10/11 all day, and we are doing Chapter 2 review. We are finishing up and preparing for the assessment. So we have lengths of 8 feet, 5 feet, and 6 feet. Those are the moves that he can make.
I only saw the 68.
I don't know. Is your book different than mine? Check it. There could be a typo.
No.
You got it?
I just did one.
Okay, so let's just do one of these, even though now it sounds like you don't really need this. To go 16 feet, well, I could easily do like 8 and 8, right? But I could make it more creative because it says show 2 number expressions that represent that. So 8 and 8 would be an easy one for 16. But if I need to make another one, I don't know, I could start playing and just do like 5 plus 5. What, Alan?
Plus 6.
Ah, plus 6. And that'll get me to 16 also. Now, if I did something awkward like 5 plus 8, crap, well then, if I add 5 or 6 or 8, I'm going to be too high. So might as well just go way too high, 16. So wait, then what do I need to do now? I have 5 plus 8 plus 8. I need to go backwards 5. So we're going to add a negative move, and that would get me to the same place. That's the same as my 8 and 8, but it's not the same because I use different moves, right? I used 5 moves as well. So, 2 different. That's also on your team assessment, so you will have to agree with each other on this. So those 2 different expressions are equal. Also, just 8 and 8 would just be kind of boring. So we will do things like that for all of these. One example for like 19. Well, think about what numbers can I make just with the 3 numbers I have. If I add 5 and 6, what do I get? 11. If I add 5 and 8, what do I get? Somebody said it. 13. If I add 6 and 8, what do I get? 14. And then, of course, bless you. And then, of course, I could double any of my numbers. 10, 12, 16. I can, of course, have multiples. So to make 19, well, if I look at this list of quick sums, I could grab my 14 and then add 5. Or I could do my 13, use 5 and 8, and then add to get to 19. I could add 6 more. There's a lot of different ways. So look at what lengths you can make when you start to add them too. Anyone need to see more off 131? Let me talk to your C or D or anything. Okay, other questions from last night that you either struggled on or you just didn't get to? 138. Now, so it's been said out loud, last time the closure activity was not part of the journal check because we had just done it. It will be part of the journal check this time. So all Chapter 2 practice, part of this journal check. It is quarter 2, so it does not affect Discovery Day, but all Chapter 2 practice needs to be done for this journal check. Sorry, Francesca, you said 138? So 138, using the numbers we have shown there, we need to produce what they've asked us for. So list 5 numbers with a mean of 5. Maybe a bit higher. Note that we may use each number as many times as we want. It's going to be useful. What does mean mean? Using that same word twice. What does mean? I feel like Alex and Marvin are running the class. Yeah. Average. Right, so how do I get average?
You add them together and divide by the number of numbers.
So I need to find 5 numbers that when I add them together and divide by 5, because I will have 5 numbers, I have to make 5. So some, S-O-M-E-S-U-M, some number that is the addition sum divided by 5 will equal 5. What does that sum need to be so that when it divides by 5 it equals 5? Nathan? 25. So we need to add up 5 numbers to make 25. Well, we've got a few options here. If I grab like the 3 and the 7, that'd be 10. And then I could grab them both again, but then I don't have a 5 here. What could I do? I don't have any ideas. If I grab the 3 and the 7, I've made 10. After?
I probably saw 2 2.5s.
But I can use each number as many times as I want.
Alright, then grab, when you have 7 and 3, grab the 10 to the right.
Ooh.
And then grab the 2, 2, and 1.
So I grab this one time and then another time. 1, 2, 3, 4, 5 numbers that I've used. We'll add up to 25, average out to 5. There are other ways we can do that as well. So what if I start by grabbing the 10 twice? So I take one 10, take another 10. I've now used 2 numbers. You know, Marvin?
Add the 3 and add the 2.
Ooh, but I need to use 5 numbers.
Oh. Wait, add.
You
Add the 3 and then add the 1 twice.
Add the 3 and then add the 1 twice.
Or you could add the 3, add the 2, and add the 0.
Or we could add the 3 and the 2. We've got 0 to work with. So if you can add a 0, what does it do? Nothing. So you could add as many zeros as you want as well. So we could have gone 10, 10, 2.5, 2.5, 0. There's a bunch of ways we could do this. Then we were asked to list 5 numbers with a mean of 5. We've already thought about that. And a median of 2.5. What's median mean, Alan?
Isn't it where you list the numbers from least to greatest or greatest to least, and then you find what's in the middle of it?
Absolutely.
And if there's like 2 numbers in the middle, you find what's in the middle of those 2 numbers.
Right. Perfect. Could not have defined it better myself. So we need 2.5 to be in the very middle, and we're going to have 5 numbers. Right? So if I look at 1, 2, 3, 4, 5, this has to be 2.5 because it's in the dead middle. All right, so what else do we use then? Penelope, what do you think? What else do we use? So 3 will go above this, right? Because they're in order. And I can only use one more number bigger. I don't know if we're going to be able to make that sum. So I gotta make 25, right? So if I've used a 2.5, I gotta pick up another half somewhere, right? So I either need to use the 7.5 or the 2.5, because those are the only ways I can pick up another half. 7.5, we can play with it. Let's see what happens. So that would then be 10. The biggest number I could put out here is 10, so I still only have 20. Yeah, but that'll only get me to 22. So that actually won't work. Just because I can't, like, I don't have, even if I put a 2 and a 2 here, that's 22, right? Or 24, sorry, but I need 25. I can't. This has to be in the middle, and 3 would go over here. Dang it. Math doesn't always work easy. Sometimes we gotta play with it. Nathan, you had your hand up. What do you think, man?
For the biggest, you can do 10 and 10. And then another 2.5.
So now what do I have? 25. Now I already have 25. And put 0. So those would be my 5 numbers that mean to 5 and median 2.5. Then it says, if a list of 5 numbers has a mean of 5, what is the largest median that this set of data can have? The largest median. Well, the median has to be in the middle in order. So we want to work with like the biggest numbers. Like we want the biggest median, right? We want this middle. That looks awkward. I could probably make the median 3 pretty easy, right? We already have a median of 2.5. What if I try making the median 7? So these numbers either have to be the same or bigger. What other numbers do we want to try out here? Renard, you want to help me? They have to be the same or bigger. We've got 7, 7.5, 9, and 10 to work with. What do you want to put out there? Sure, let's try that. So now we have 14 and a half, 23 and a half, right? Yeah. So what else then? But wait. So if this is 23 and a half, and I need to get another half. Wow, that doesn't work. The half screws me up. Right? This, I don't want this half, because if I didn't have that half, I could just put like a 2 down here. Right? And then a 0, of course. What can I do? Alan?
Can't you, like, put another 7?
Yeah. I can use the 7 multiple times. So if I put another 7 there, and then take away the half, this is still the median. 7 is still my median because these are still in order. Exactly what Alan said. Median is middle with data in order. But is that the biggest that we can get? Play with this for a minute. Take like a minute on your own. Play with, could we list 5 numbers that will add up to 25 and have a bigger number in the middle? those are really our next two options, right? 7.5 in the middle and 9 in the middle.
You don't have to keep it. You're fine there.
This is also your time if you don't need this problem. If you've already done it, you can be working on other stuff. This is just a review day to benefit you. We just talked. Delaney, if I put 7.5 in the middle, what would you put here? Got to be the same or bigger, remember? I can't put just a 7, but I can put a 7.5. Because I can't put a number that's less on the right. The less numbers have to go over here. 7 could go here, but then I think we'd be in danger of maybe getting too large. But we could put a 7.5 over here, which then would make what? What does this add up to? 15, right? What number do we want to try here? It's got to be the same or bigger, right? So I could either do another 7.5, or I can do the 9, or I can do the 10. And we know this is 15. What if I put a 10 out here? Will it work? Alex? I could just put 0, 0 over there. What if I put a 9 out here? It's still bigger than 7.5. It'll work. So I don't really like that yellow switch. Can I put a 9 out here? Instead of the zeros, what would we have down here? Yeah, 1 and then a 0. So that works. The 7.5 could work. Matt, what about the 9? If I put the 9 in the middle and try to make this happen, what would have to be in these spaces? 9 or 10. Yeah, Marvin already said, but so Matt, what do you think? If I put, will this work if I put 9 in the middle? Did you get a chance to play with this yet? Yeah, no worries. So like the least numbers I could put out here are 9s, right? I could do the same. The least numbers I could put down here are 0s. What do these add up to? 27. Doesn't work. So the largest number that we could have in a list of 5 with a mean of 5, 7, for the largest mean. Other questions from last night? It's okay if your closure is out of order. It's always okay if your work is out of order. If you like ask a question or if we work on it in class and you write stuff down and then you go back to problem 135 or something, that's fine. Somebody was freaking out that their homework was out of order and they redid it. Never do extra work just to do work. It needs to be purposeful. Other questions? What do we got? Anything. Even if you just haven't done it. Aubrey? 130A. 130A?
I got
130. Oh, of course. This is a weird one. Thank you for asking. So our objective here is to convert into decimals, or vice versa. Now, our calculator can try to do this, but be careful, because we can only trust our calculator so much. So, Ella, what is the first step when I approach a fraction? I hadn't even turned to look. I'm sorry. I'm just going through the cards. That happens. Allie, what would be the first step when I go to convert an improper into a mixed? Because we want a decimal, which decimals are mixed. Which, by the way, if no one's ever told you that, just like mixed numbers with fractions are mixed, decimals are mixed, whole pieces, partial pieces. So what would we do first, Allie? Yeah, we could do the division. Now, I'm afraid of long division. I'm not joking. I was bad at it. The only thing I remember is that the numerator goes inside. I mean, I know how to do long division, right? I'm being a bit dramatic, but I don't like long division. If we went to do long division, the first thing we'd think about is how many 9s go into 13. We can do the same thing over here without setting up long division. So how many 9s can fit into 13? Just 1. Then, how many do I have left over? 4. So great. My decimal will be 1 point. Ah, crap. Because 4/9. Now, if this was 4/10, party, sweet, awesome, we're done. But it's not. Now, we remember that there is a rule, a trick, a whatever you want to say for dividing by 9. But can anybody tell me how you solved this? Did you just use the trick, or did you do something else? Use a calculator? The calculator's going to lie to you if you do this. The calculator will lie to you if you do this. I will warn you. No, not this one, sorry. If you did 5 9s, it would lie to you. Then we divide by 9s. Like we had that whole lesson where does 0.9999999 forever equal 1? Because we said any number divided by 9, do you remember the rule? It repeats the numerator. So we can show this through a division problem that we practiced, and we're actually coming back to that in future chapters. But what 4/9 does is repeat 4. Because if we set up the long division, zero 9s fit into 4. But 4 9s can fit into 4D. But every time you multiply a number by 9, you get that number we're shooting for minus the number we just used. So we get 4 left over. If you do it with 5, you get 5 left over. You do it with 7, you get 7 left over as your remainder. And this will continue forever. Because we do it again, and we get 36 with 4 left over. We do it again, and we get 30, and it happens forever. Works with any number when you divide by 9. So if you want to remember the rule, if there's a 9 in the denominator, the numerator just repeats itself. So we can use the Repeten bar. If I don't use the bar, what do I use? Who knows the name? Patrick. Ellipse. The dot, dot, dot. Now we don't use both, but we can use one or the other. Okay? Now I didn't mean to do that with highlighter, but we like the repeating bar. It's just more straightforward. Other questions? Or you good? Sweet. Other preguntas. Like from a different homework. Do you remember what homework it was from? That would just help me. Anyone know what homework 84 was from? 224. Ah, it was so close. Ah, okay. So we went over this once in class, but it's worth going over again a little bit more in depth, especially since we have time today. A histogram. And we looked it up in the back of the book because we have our glossary that can help us. But we never, finished solving this because at that point, wanted you guys to try it again. What is the first most important thing if we've been asked to find mean and median? And Alan brought this up when he was talking about the median. But really important, if you're going to find the median, we first, Emily, have to do what? List the numbers what? Yeah, some of you guys are just really quiet, or maybe I'm just really loud. We had to list them least to greatest. So this is my least favorite part of solving math, when I have to order numbers. Because ordering numbers, it's stressful, right? What if I forget one? What if I have to squeeze one in? So sometimes when I order numbers, I write them big. So if I have to erase and fit one back in, I have space. Lowest value up here. 34, I believe. Let's make this smaller so I have some more space. Somebody help me out. 39. It's up there too if you want to help me. 48. Wait, what? Wait, after 56, what? Crap, sorry. Another 61. What? Are there seriously 4? 1, 2, 3. There are. Okay, what now? 76. Oh, come on. 83, 84. Oh, come on. Don't. Okay, there we go. 83, 84, 88. All right. Histogram. A histogram is a fancy name for a bar graph, but it's a specific bar graph. To make a histogram, we need a y-axis that will show the frequency or how many times something happens, and an x-axis telling us the what that happened. Now the specificness of this problem comes in when it tells me how many bins I have to have. And if you looked at your glossary in the back, it shows you what to do. We obviously start our frequency at 0. The least amount of times we could do something would be 0. But our x-axis does not have to start at 0. Where do my values really start? Like my list here, what do I start at? 34. What would be a good number to start at if I need to make bins or sections with a width of 15? What number could I start my sections on the bottom at? Which, by the way, 84, I'll just tell you guys, 84 is one I'm spot checking. If you don't have a histogram made, your math journal will be a progressing. So if you decided that on 84 you were going to slack off and hope that I didn't, like, come on. I'm just going to be nice and tell you I'm checking that problem. Make sure you have a histogram. If not, make it now. Go back to that homework. Look for 84. Do you have a histogram? I bet a lot of us don't. Which is frustrating because I've given us days to ask questions. I still love you. I just wish you would ask me more questions. I want to, like, earn my money. Which is not much money, but I want to earn it. Teacher salary, it's all public knowledge. You can look up any of our salaries if you want. We could start our graph at 30 because then it has to be a width of 15. So my next value would be 45. My next value would be 60. My next value would be.
Good morning, Sebastian and Santiago Pinto.
And my next value.
Sebastian and Santiago Pinto, please come to the office.
In those 4 sections, can I fit all my data?
Yeah.
Wonderful. Now figure out what your frequency is. How many are between 30 and 45? Just 2. How many are between 45 and 60? Apparently I got too loud. How many are between 60 and 75? How many are between 75 and 90? Well, the rest of them. Now we make our bars. Is anyone confused at this point? Any questions? All I did was break things up. So because I love highlighters, I just broke them up with colors. Do not relate this yellow with that yellow. There are 2 different yellows. The pink is way too dark. So how many did I have that would fit between 30 and 45? 2. So now I have to give some frequency. There's 1, there's 2, 3, 4, 5, 6. I hope none of them have more than 6. Of course, that one has 7. So there's going to be some 7 where my bar is higher up. I'll be able to make it, though, because I have space over here. So I make a bar too tall that spans the entire distance between 30 and 45. And I shade it in. How tall should my next bar be? If you can't figure out 3, ask somebody around you. There's 3 numbers. Frequency is how many? 3 numbers. So I just make this 3 tall. And it spans the whole width. The other big thing about frequency, or about histograms that kids get wrong, these bars have to be right next to each other. Now, if a bar has a frequency of 0, there's just no bar. But the spaces, the ranges, have to be right next to each other. So this range, I should actually probably color it in green. How tall will my next bar be?
Sounds like you're saying Barbie.
Barbie! You can do anything with Barbie. They have like some new ad campaign, which I like. What? You never played with Barbies? Come on, how else are you going to figure out what heels look good?
You are an
So we go 4 tall because there are 4 numbers in that range. And we'll continue to work on histograms this year, by the way. So don't freak out if this is still a challenge to you. How tall is my next bar? 7, which is annoying because my graph isn't quite big enough. So I'm going to go off my graph a little higher at a frequency of 7. Yeah, shade it in somehow. You don't have to shade it in very intensely, but one nice thing about shading them in is then I can make them look different. So if 2 of my bars had the same height, I would like to shade them slightly different. Like one, I might do lines this way, and then the other, I might do lines this way, so that they're not going the same direction. So you can see where the bars split and where they're 2 different things. But these are all easy because just stair steps. So maybe this is like age of people in the retirement home cafeteria or something like that. Most of them are really old. Some of them are younger. Some of them might be employees. I don't know what we're graphing, but it's some kind of data. And I don't think we have anything to label the bottom histogram. Heights. Sorry, heights of sunflowers. Oh, my mom's sunflowers are taller than this. So your x-axis, make sure we label down here heights of sunflowers, because it told us what we were graphing. Heights of sunflowers. Other questions from last night's closure or any of chapter 2? I will also be recording the afternoon class. They will probably ask some other questions. So if you're curious, you can ask somebody from the afternoon class what we went over, or you can check out that video. On it. 134. Back to closure. Right, that's in closure. George is playing a game. Or Jorge. We really want to be cultured. He's got a spinner, right? His spinner's incomplete. Oh no. Now, George is having an issue. Why? Who can explain why George is struggling? Aside from the fact that he doesn't go to Phoenix. Now, Grant, why is he struggling?
Well, all his fractions are not.
All his fractions aren't working together very well because they don't have a common denominator. These denominators are problematic for George. So, yeah, and so we tell George, like, all right, man, your life will be a whole lot easier if you just, what? What do we what? do we tell George to do? Man, your fractions will be easier to make common denominators. So, to help George make common denominators, we are going to utilize what? Something I never used or never knew about until CPM. It's really big, but it only means this.
Oh, the big.
Yeah, the giant one, right? So 2/5. What would be my common denominator? If I'm working with 5 and 3, what can be common? 15. So I need 2/5 to equal something with a 15 on the bottom. To get there, we're going to multiply by a giant 1, which if you have forgotten about this, please write it on your paper again. You do not have to be very artsy. What will make a giant 1 here and make my denominator equal 15? Yeah. 3/3. You have 3/3, you just have 1. That equals 6/15. So I would write somewhere, hey man, this is really 6/15. Then we're going to do the same thing with 1/3, except there, my giant 1 should be, Francesco, what's my giant 1 here? To get a denominator of 15. What do you need to multiply the denominator by? 5. So our giant 1 is 5/5. And this will equal 5/15. So we can tell him, hey, this is really 5/15. He wants to know what he has left over. Alex, how can we do that? Yeah. If this thing had been broken up into 15ths, the whole thing is 15 of them. So exactly what Alex said, take 15, subtract away what we've already used. Well, how much have we already used? 11, so we have left over. Now, this is something that my Math 2 kids were struggling with yesterday, my 8th graders who are 2 years accelerated. Do not trust what things look like. When I look at this, these regions all look pretty much the same. They're not, right? Trust the math. Do not trust your eyes. Your eyes will play tricks on you. Especially if you're in a completely dark room, you will hallucinate. Yeah. If you are in complete silence, your brain will make up noises. If you are in complete darkness, like literal absolute darkness while your eyes are open, your brain will hallucinate. It will try to see something. Patrick?
129. I got the answer, but I don't understand how.
Don't you find that interesting when you get the answer and don't know how? 129 is from 232, right? Oh, okay. So it's like a rationalizing question. It's saying, like, make sense of what we're saying. So this is really just like an explain in your own words type problem. So use your reasoning, not what I taught you. I mean, it can be what I taught you, but whatever it comes out of your brain. Why does this happen? So if multiplying by 1/4 makes a positive number smaller, right? I have 4, I don't know, 4 something, and I multiply them by 1/4. What's 1/4 of 4? Well, if I was going to go by 4 tires and I find out I can only afford 1/4 of them, I'm going to get 1. Sorry, your hand was a little like it was peripheral. What then does dividing by 1/4 do to the value of a number? Turns it into fourths. What does it make with like? So say we start with 7 pizzas, right? Our problem is we're starting with 7 pizzas. Can you explain how 7 divided by 1/4? Like you said, it's going to turn it into quarters, but I mean, I agree. But what does this answer actually become? Do you know? So let's say you get 7 pizzas, right? We divide them each into quarters, exactly what you said, which is the dangerous thing about thinking through multiplication versus division. If I cut things up, we're dividing, but we're dividing it into quarters, so we actually end up with how many slices?
No,
7 pizzas cut into quarters, and you get why is what this is saying. You could type this in a calculator and figure out the answer. But why? Well, if I start with a quantity and cut into pieces smaller than what we started, how many pieces will I end up with? More. That's like saying, if I start with a piece of paper, and I divide this by a quarter, why do I now have more? Because the pieces are smaller, but I have more of them. That's what it wants you to rationalize through. However you explain that. So this is where I like to see your own, like, how you speak about math, or write about math. B, if multiplying by 1 does not change the value of a number, if I am one me, if I have one set of markers, if I have one order of pizza, it's just what it is, then what effect does multiplying by 2 over 2 have? You asked, yeah, sure.
well, it's 1.
2 over 2 is 1. Yeah. Now, it actually does have an effect. Because if I start with 7 pizzas again, I can say 7 over 1, and I multiply by 2 over 2, I get 14 over 2. So it does kind of have an effect. But now what this would mean is I took my 7 pizzas and did what? I multiplied by 1. I heard you, but be careful. I multiplied each individual number by 2, but I really multiplied by 1 here. We're way running out of time. I didn't really double. I cut my pizzas into halves, but I didn't take them apart. So now what I have is 14 half pizzas, and I still have 7 pizzas. Here I took the pieces apart and handed them out. I have 28 fourths, which would equal 7 if I did that, but I took the pieces apart. Here I just said, well, how many halves do I have? Well, you have 14 halves making 7 pizzas. So we will take your team assessment tomorrow, and then individual assessment and math journal check on Friday. Have a wonderful day, guys. Today is Wednesday, right?
Yeah.
It is.
I do not. We would not be able to fit in what I need to fit in this